Okay, on page 4 in your notes, we're going to do inverse variation, but before we do that, I just want a quick review one more thing about direct variation. So examples 4 and 5 here are dealing with the direct variation graph, and as you remember from last class, the graph of a direct variation, it needs to be a straight line, and it needs to go through the point 0, 0. So what we're going to do is we're given one point of the direct variation, and the example asks you to plot 3 other points on that line. So let's start with, we know it needs to be a straight line, and we know 2 points can make a straight line. So it needs to be a straight line, and it needs to go through the point 0, 0. So I'm actually going to start by plotting 0, 0, and then I can take my ruler and connect those 2 points and draw a straight line. I know it needs to go through 0, 0, and I know it needs to be a straight line. And now it says plot 3 other points on that line. Well, we already have 1 point, so let's just plot 2 others. Okay, it doesn't have to be those points, it could be any points on the line. But there you have your 3 points. Okay. So let's do the same thing for part B. We have negative 3, 3 already on the line. We need to plot 3 other points. Well, let's start with an easy one, 0, 0. Then we could draw a straight line. And now we just need to plot 2 more points on the line. So there's one. Let's see if I can find another one. There's another one. I mean, you could plot anywhere on that line, but um, just, a couple examples. And the way you can check is you can take your points, like if you do the point negative 3, 3, if you do y divided by x, that gives you negative 1. Well, look at the point I plotted here, negative 2, 2. If I do 2 divided by negative 2, that also gives me negative 1. So if you take those points and do y divided by x and get the same number, you know you did it right. All right, inverse variation. So to start, let's review the direct variation equations. You'd have y equals kx, or k equals y over x. Okay, remember, this is the primary equation, this is the secondary equation, just to help you solve some problems. And the graph is just a straight line that goes through 0, 0. Now with inverse variation, the main equation you're going to use every time I want you to write an equation, we always want our equations to start with y equals. So in inverse, it's going to be y equals, and instead of k times x, it's going to be k divided by x. Okay, so it's the opposite of direct in that you're dividing, k divided by x. Um, and then the secondary equation that you can use just to kind of help you solve some problems is k equals x times y. So instead of dividing, you can multiply x and y to get k. And what that graph looks like, it looks a little weird. Um, it looks like this. It's the inverse variation graph where there's what we call a vertical asymptote at 0 and a horizontal asymptote at 0. Basically, these lines get closer and closer and closer to the y-axis and closer to the x-axis, but they never actually cross the x-axis. All you need to be able to do is recognize this pattern, though. Like, recognize that that's the sketch of an inverse variation. You're not ever going to have to create the graphs. You just need to recognize that's what they look like. Okay? And then domain and range. Let's not worry about these. Okay, so you can cross that out. All right, on the next page we have some examples. So example 1, determine if each equation is an inverse variation. So we're just looking at the equations. So we either want y equals a number over x, or we want x times y equals a number. So if you look at the first one, that is an inverse variation because it's a number divided by x. Or, remember our secondary equation, part B, if you have x times y and it gives you a number, that is also an inverse variation. Okay, so 2 ways to recognize an inverse variation. C isn't quite as straightforward, so what I'm actually going to do is I'm going to solve for y. And what do you get when you solve for y here? Get y by itself. You get y equals 3x plus 4. And what I'm looking for is a number divided by x when I solve for y. Do I have a number divided by x here? No, I do not, so it's not an inverse variation. Do the same thing with D. Solve for y. So when in doubt, you solve for y. Y is 4x minus 2, because I had to bring that 2 to the other side. And if it's not a number divided by x, x needs to be in the denominator, then So when in doubt, either look for this number divided by x or x times y equals a number, or when in doubt, solve for y, get y by itself, and if it's not a number divided by x, it's no. Okay, example 2, write an inverse variation in which y equals 5 and x equals 3. So to start, it's a lot like direct variation where we need to find our constant first. So we're going to use the secondary equation, xy. And what am I going to plug in for x and y? I'm going to plug in 3 for x and 5 for y. And what's 3 times 5? That gives me 15. So my equation is just y equals, and plug it into the first inverse variation, so 15 over x. Let's do that again. Okay, so example 2, write an inverse variation in which y is -3 when x is -6. So first thing I need to do is use the secondary equation to find my constant, plug in x and y, and what do you get for your constant? You get 18, so what's the equation when you plug it into the first equation? You get y equals 18 over x. So try your turn 1 and check your answer. Okay, for your turn 1, you should have gotten y equals 4 over x. All right, in example 4, now we're taking it a step further. Not only do we have to write the equation, but we need to find a missing variable. So it's the same process as examples 2 and 3. Okay, suppose in an inverse variation that x1 equals 3, y1 equals 2, and y2 equals 6. Find x2. So the whole first part of this, we're going to do exactly what we did in examples 2 and 3. We're going to use our secondary equation, but what am I going to plug in for x and y here? The x and y I'm going to use the x1 and the y1 because they go together, okay, because they both have a little subscript of 1. So I'm going to plug in 3 and 2. So what's my constant? 6. Now I'm going to do the same thing in example 2. I'm going to write my equation. Y equals 6 over x. But now I need to find, now I'm given a second y value and I need to find the x value. So I'm going to take this equation here and I'm going to plug in 6 for y. So I'm going to rewrite it, but instead of y, I'm going to write 6. Okay. And now I have an equation in which I'm solving for x. Now this gets a little weird because x is in the denominator, and I know you guys have seen this before. To get x out of the denominator, I'm going to multiply both sides by x just to get it out of there. So what happens is x actually moves to the other side, but now it's in the numerator. So now I have 6 times x equals 6. The x is canceled out here. So I just have equals 6. And now how would I solve for x? I'm going to divide both sides by 6. And what's x going to be? X is 1. So when y is 6, x is 1. Let's do that one more time, example 5. Okay. So first thing I'm going to do is use the secondary equation. I'm going to multiply x and y. What am I going to plug in for x and y in example 5? I'm going to do 2 times -6. So what's my constant? That's -12. Now I'm going to plug it into the primary equation. So what's my equation here? Y equals -12 over x. And now it says the second point is -4 question mark. Am I going to plug in -4 for x or y? I'm actually going to plug in -4 for x. So this one's actually easier than example 4 because look what happens. I plug in -4 for x, and now I don't even really need to do any solving like I did up here. I could just divide. -12 divided by -4, what's y going to be? +3. So there you go. When you're given 2 of the numbers in the inverse variation, you can figure out what the match would be if you're given a third number. You have to follow this process. Don't skip any steps because they might throw you a curveball like in example 4, and they might give you y instead of x. So you do need to actually write out the equation. A lot of people were skipping that step with direct variation. You do need to actually write out the equation and then see where your number plugs in. All right, the last part, example 6, tell whether each relationship is an inverse variation. This kind of tells you what to do. Just do x times y and see what you get. So for 1 and 30, we do 1 times 30. What does that give me? 30. Okay, 2 times 15. What does that give me? 30. And 3 times 10. What does that give me? 30. So yes, this is an inverse variation because for all values of x and y, you always get 30. Let's try over here. So we do x times y. What's 9 times 2? 18. What's 7 times 3? 21. And what's 5 times 4? 20. So did we get the same number every time? No. So no, it is not an inverse variation because xy was not the same every